9.5 linear equations. A first order linear differential equation is one that can be put into the form equation 1 dy over dx plus big P of x times y equals big Q of x, where big P and big Q are continuous functions on a given interval. This type of equation occurs frequently in various sciences, as we will see. An example of a linear equation is x y prime plus y equals 2x, because for x not equal to 0, it can be written in the form uh, equation 2 y prime plus 1 over x y equals 2. Notice that this differential equation is not separable because it's impossible to factor the expression for y prime as a function of x times a function of y. But we can still solve the equation by noticing by the product rule that x y prime plus y equals open x y closed prime, and so we can rewrite the equation as open x y closed prime equals 2x. If we now integrate both sides of this equation, we get x y equals x squared plus big C, or y equals x plus big C over x. If we had been given the differential equation in the form of equation 2, we would have had to take the preliminary step of multiplying each side of the equation by x. It turns out that every first order linear differential equation can be solved in a similar fashion by multiplying both sides of equation 1 by a suitable function big I of x, called an integrating factor. We try to find big I so that the left side of equation 1, when multiplied by big I of x, becomes the derivative of the product big I of x times y. Equation 3, big I of open restarting equation 3, big I open x close open y prime plus big P of x times y close equals open big I of x times y closed prime. If we can find such a function big I, then equation 1 becomes open big I of x times y closed prime equals big I of x times big Q of x. Integrating both sides, we would have big I of x times y equals the integral of big I of x times big Q of x dx plus big C. So the solution would be equation 4, y of x equals 1 over big I of x times open bracket the integral of big I of x times big Q of x dx plus C close bracket. To find such an I, we expand equation 3 and cancel terms. Big I of x y prime plus big I of x times big P of x times y equals open big I of x times y close prime equals big I prime of x times y plus big I of x times y prime. Big I of x times big P of x equals big I prime of x. This is a separable differential equation for big I, which we solve as follows. The integral of d big I over big I equals the integral of big P of x dx. The natural log of the absolute value of big I equals the integral of big P of x dx. Big I equals a times e to the power the integral of big P of x dx, where big A is equal to plus or minus e to the power big C. We are looking for a particular integrating factor, not the most general one. So we take big A equals 1 and use big I of x equals e to the power the integral of big P of x dx. Thus, a formula for the general solution to equation 1 is provided by equation 4, where big I is given in equation 5. Instead of memorizing this formula, however, we just remember the form of the integrating factor. To solve the linear differential equation, I prime plus big P of x times y equals big Q of x. Multiply both sides by the integrating factor. Big I of x equals e to the power integral of big P of x dx, and integrate both sides.